we have two questions here. We're going to try to tackle both of them. We have one, draw a graph of f at x such that f at -2 is equal to 12, f at 3 is 4, f at 0 is -5, and f at 6 is 7. Think of each of these as a set of coordinates, okay? Remember, this is f at x, which means that this is the x value, input it, and then think of the equal side, so the right side of the equal sign, as being the y value. So think of these as sets of coordinates. First one being -2 and 12. The second one being 3 and 4. 0, -5. And, oh, I lost the cursor. There it is. 6 and 7. We're going to plot these and see if we can kind of figure out some type of graph that fits these coordinates. So let's jump into Desmos here. I'll turn off some of the previous things we had. Okay. I'm going to actually plot these as, oh, it won't let me do a table. Well, yes, it will. There it is. I want a table. Our values were -2 and 12, which is 1, 3 and 4, 0, -5, and 6 and 7. Okay, so we're going to zoom out a little, and it looks like this is what we have. So we have this being the leftmost. This is the second coordinate if we're going from left to right. This is the third. This is the fourth. So it's possible, we're going to make a guess at this, that this is some type of function that's probably traveling downwards, coming down, and it looks like it turns at this point, starts heading up, and then maybe heads in that trajectory of some kind. So some fun type of function that probably goes like this, if it was continuous. If they just want the graph of this, we actually don't include this continuous line, and these are just the coordinates. This is technically the graph of f at x. One coordinate with another coordinate, and another coordinate, and another coordinate. So it depends if the question is asking us to fit a graph to this, or just draw the graph of this, okay? In this case, it said draw the graph of this, so that actually works out as the graph. We can use something called regression, but that's not really in our level of mathematics to try to fit a specific type of graph to this, like maybe a quadratic or a quartic function of some kind. But let's just focus on the other question we had too. Draw the graph. So in the graph, assuming it's not continuous, we really just got to get these sets of coordinates. Same concept, here's g at x. So in this case, coordinates are 0 and -6, 3 and 4, -10 and 2, and 1 and 3. Same idea as before, we just need to plot them. So when we go to plot these, insert a new table. And our very first one is 0, -6, 3, 4 again. It's a popular one. Where did it go? -10, value of 2, and 1 and 3. Okay, so same idea as before. Change it to purplish. Where's purple? There it is. So we have our coordinate here. There's one of them. So this is our -10 and 2. That checks out. That's this value here. We have one at 0, -6. That's this one. It checks out. This one is 1 and 3, it looks like. Yep, that checks out. And this one's kind of covered, but it is here. That's our 3 and 4. So those are our coordinates that check out again. If they ask us to fit something continuous, same idea. We're usually traveling from left to right. So maybe it comes across, dips down, jumps up very quickly, and heads out in this direction. But if we're not being asked for a continuous trend line to be fit to this, then we really just have the coordinates that we had from before.